Welcome! Today we're building a complete toolkit to absolutely master permutations. We're going to turn those complex arrangement problems into simple, solvable puzzles.
So here's our game plan. We'll start with the core idea, build up our toolkit with some must-know formulas, then tackle a few tricky special cases. After that, we'll solve a real exam question together and finish it all off with a cheat sheet to make sure it all sticks. Okay, let's dive right in.
All right, first things first. Let's get a really solid grasp on the fundamental concept. What exactly is a permutation? And why is the order of things so incredibly important?
Let's start with a really simple question, just to get our brains warmed up. You've got A, B, and C. How many different ways can you line them up? Just take a second to think about it.
If you thought 6, you are exactly right. Each one of these is a unique arrangement, or, as we call it, a permutation. And that's the absolute crucial point. In the world of permutations, ABC is a completely different thing from CBA. This one simple idea that order matters is the foundation for everything we're about to do.
Okay, now let's start building our toolkit. These next two principles are basically the master keys that are going to help us count all the possibilities without having to list them all out one by one.
Think of it like this. If you need to do task A and task B, you multiply the possibilities. But if you can do either task A or task B, you just add them up. It sounds simple, but this little distinction is fundamental for solving pretty much any complex problem.
Now, to make all this counting way faster, we have an amazing power tool called the factorial. It's really just a shorthand for multiplying a number by every single whole number smaller than it all the way down to 1.
But what if you don't want to arrange all the items? What if you only want to pick and arrange a few from the group? Well, for that, we need our main power tool, the permutation formula.
And here it is, the classic permutation formula, NPR. All this really tells us is how many ways we can choose and arrange our items from a bigger pool of n items.
Let's use it right away. So to find the number of ways to arrange 3 letters from a set of 5, we just plug the numbers into the formula, we do a little bit of simplifying, and there it is. We get 60 possible arrangements.
Our toolkit is getting pretty powerful, but now we need some specialty attachments. For those situations that kind of break the standard rules. Let's run through these real quick.
So on the left, if you can reuse items, think about a PIN code for your phone, the possibilities grow exponentially. But on the right, if you've got identical items, you actually have to divide to get rid of all the duplicate arrangements.
And this is the classic example that illustrates that identical objects rule. We divide the total factorial of all 11 letters by the factorials of each repeated letter. That's the 4 I's, the 4 S's, and the 2 P's. And that gets us the true number of unique arrangements.
Now, when you're arranging things in a circle, one position is always considered fixed, so we use n-1 factorial. And for something like a necklace, right, where you can flip it over and it's still the same design, we have to divide that by 2.
Okay, our toolkit is officially fully equipped. Now let's apply it to a real exam question and see how all these tools work together to just dismantle a complex problem.
This is a classic restricted permutation problem. The condition is that no two girls can sit next to each other. To solve this, we're going to use a really clever technique called the gap method.
So here's the logic. It's pretty cool. First, we seat the boys. This creates these empty slots or gaps between them and at the ends. Then, we simply place the girls into those gaps. That guarantees they'll never sit next to each other. The crucial final step is to multiply the results from each step.
And there's our answer, 14,400 possible seating arrangements. See how the toolkit breaks a really tricky problem down into simple, manageable parts? Okay, to wrap this all up, let's consolidate everything we've learned into one super handy reference that you can use anytime. Here are the most important tools from our kit, all in one place. Seriously, this slide is your go-to reference for solving almost any standard permutation problem you're going to come across.
And finally, let's be aware of these common mistakes. Knowing what not to do is honestly just as important as knowing the right formulas to use.
From passwords and playlists to seating charts at a wedding, the world is just full of arrangements. Now that you have the tools to calculate them, it kind of makes you see the hidden complexity in math in everyday life, doesn't it?